A company recently introduced a new electronic control device for homes. In one city, the number of households, H in thousands, that own the device T months after observations began can be modelled by H of T as 30 over 1 plus 2e to the negative 0.05t. Use the model to determine the maximum number of households expected to own the device. So that's when T tends to infinity. So H would then be equal to 30, because this bit here will go to 0 and you've just got 30 over 1. And don't forget that's in thousands. So 30,000 households. There's only one mark there, so if you just put 30, you're going to lose that mark. How long will it take for the number of households owning the device to double from the initial number? So the initial number is H of 0. So e to the 0 is 1, so it's 30 over 1 plus 2, 30 over 3, which is 10. So what we need to solve is we're going to double the initial number, so we need to solve 20 is equal to 30 over 1 plus 2e to the negative 0.05t. And I just paused while I typed that into the calculator, and we can see that t is 27.73, or approximately 28 months. Show that the rate of change of the population satisfies the equation h-t is kh30 minus h, and determine the value of the constant k. Now this is fraught with huge algebraic rabbit holes, so you could go a long way around this. I'm going to try and do it reasonably efficiently if I can. So I'm going to rewrite that h of t up there as 30 1 plus 2e to the negative 0.05t to the negative 1. And then h dashed of t would be negative 30 1 plus 2e to the negative 0.05t to the negative 2 multiplied by the differential of the inside here. So we're going to need 2 times 0.05, which is 0.1. So we're going to have negative 0.1 e to the negative 0.05t. So negative 0.1 times negative 30, that's going to be 3. And then we've got 1 plus 2e to the negative 0.05t to the negative 2 multiplied by e to the negative 0.05t. So that's going to be 3 e to the negative 0.05t over 1 plus 2e to the negative 0.05t, all squared. Now I'm going to call that 1, and I'm going to come back to it. Now remember that h of t was 30 over 1 plus 2e to the negative 0.05t. Now rearranging that, we get 1 plus 2e to the negative 0.05t is 30 over h, and also 2e to the negative 0.05t would be 30 over h, take away 1. So let's sub those into 1. Well, we'd have 3 over 2, 2e to the negative 0.05t on the top. On the bottom, we're going to have basically 30 over h squared. So that's going to be 3 over 2 30 over h take away 1, and then flip this upside down, it's going to be h squared over 900. So 3 in the 900 will cancel down to 300 and bring that out here, and I'm going to get 1 over 600 when it multiplies that 2. And then if we take one of those h's and just pop it there because we've got an h just there, and the other h we multiply into here, we end up with 30 minus h, which is perfect, exactly what we want, and therefore k equals 1 over 600.